Alright, so this is going to be another video about horizontal asymptotes. We have another 5 examples to go through, and hopefully this helps you understand the concept a little bit more. So it says find all horizontal asymptotes of the following functions. So let's start with 11 here. So right away with 11, you can see the degree on the top is 0 and the degree on the bottom is 2. Because there is a higher power on the bottom, this is automatically going to end up being 0 for the horizontal asymptote. Now, that was very conceptual compared to like algebraically, like breaking it down. So I'm actually going to do that right now. So we have the limit as x approaches infinity for this, and we have 3 over x squared minus 25. Okay, well, we're going to infinity, so this 25 is meaningless. And now we have 3 over infinity squared. Well, 3 divided by a humongous number that's getting bigger and bigger and bigger is going to tend toward 0. You can kind of think of it this way. If you had 3 pizzas and you were dividing it by infinitely many people, each person would basically get no pizza because there's so many people and there's only a limited amount of pizza. One way of looking at it too is if, like, say you had 3 pizzas and you were dividing it by 1 person. Okay, so that means that 1 person will get 3 pizzas. Okay, but now what happens if I made it 10 people? 10 persons. Okay, well, 3 divided by 10 here would be 0.3. Okay, well, what happens if I did 100? Well, that would be 0.03. Okay, well, what if I did infinity, where it's 1 with infinitely many zeros at the end of it? It's going to basically be 1.000000000, just 0 repeating, and then there's a 3 at the end. Long story short, you should notice the trend. This is getting closer and closer to 0, which is our answer for this problem. So when in doubt, think about it like pizzas. You're doing 3 pizzas divided by infinitely many people. Basically, everyone gets nothing. All right, let's go to number 12 here. Now, right away, you should see that the degree on the top is 2 and the degree on the bottom is 2. So you're actually going to have a horizontal asymptote for this one. Let's do the limit as x goes to infinity of x squared minus 2, all divided by x squared plus 2x minus 3. Now, again, what you can do is get rid of this, this, and this, and just look at the x squareds. X squared over x squared is going to be equal to 1. So then you have your horizontal asymptote. If you tested it out with negative infinity, you would get the same answer, so I'm not going to waste time doing that. But you end up with 1 here. Okay, let's go on to the next one here. Okay, right away you should see that the top has a degree of 2 and the bottom has a degree of 1. So because of that, the top is bigger, you should have no horizontal asymptotes. Okay, if the top is bigger, you're going to be going to infinity or negative infinity, which means you're not going to have any horizontal asymptotes. To show this more algebraically, let's do the limit as x approaches infinity of x squared minus 5x minus 4, all divided by x plus 1. Okay, the 4 is meaningless, the 1 is meaningless. Now there's x's on all the terms on top and x on the bottom. So I'm going to divide the top and the bottom by x, and you're going to be left with x. That ends up being x. This ends up being just negative 5 because you divide the x out. This ends up being a 1. So you're left with x minus 5 over 1. Well, the 5 is meaningless, so you're left with x over 1. Well, x is going to infinity, so you end up with infinity here. So because you have infinity, it's no horizontal asymptote. If you wanted, you could actually check the exact same thing with negative infinity, and this would just be a negative infinity for the answer. Either way. Okay, 14, we have a higher degree on the bottom. So hopefully you see that right away. It's a higher degree on the bottom, so that means you should end up going to 0 because you're dividing by infinity technically. So let's break this down algebraically so it makes more sense. X is going to infinity. We have 5x over x squared plus 9. That 9 is meaningless because we're going to infinity. We can divide the top and the bottom by x, so that's gone. It's just 5. This one's 5, or this one's just x, so it's 5 over. So this one's just x on the bottom. We have 5 over x. If you had 5 pizzas divided by infinitely many people, everyone basically gets nothing. So your answer for this one should be y equals 0. And the last one is a little tricky because it has horizontal asymptotes and vertical asymptotes in the same problem, but it's kind of cool. So let's look at A here. So this is a horizontal asymptote of y equals 3 and a vertical asymptote of x equals negative 2. Okay, so we need to create a function that has that property. So we're going to say f of x is equal to, so let's do the horizontal asymptote first. Let's actually do the vertical asymptote first. So we know that if the vertical asymptote is -2 there, the bottom, if you plug in -2, has to be 0. So if I plug -2 into this, you would get 0 on the bottom, so that checks out for this vertical asymptote. We just need to do the horizontal asymptote now. Now if we're going to infinity on this, and we have an x on the bottom, we have to make sure that there's an x on the top as well. Okay, if we're going to infinity, the x and the x are going to cancel, and you'll just be left with 1 because that 2 is meaningless. But we want it to be equal to 3, so I'm just going to put a 3 in front of this like so. Okay, so if you did this and you were trying to find the limit of this as x goes to infinity, you'll notice that the 2, that plus 2 is meaningless here, and then cancel, you're left with 3, which is what we want. So one of your possible answers that you can have is this thing right here. There's infinitely many answers you could put in here. This is just the one that I made up. So, but if yours is something different, but it still works out to have a horizontal asymptote of y equals 3 and a vertical asymptote of x equals -2, then you should be good to go. Okay. Let's go on to the next one here. So B, it says a horizontal asymptote of y equals -1 and a vertical asymptote of x equals 3. So I'm going to do the same kind of thing here. I'm going to, let's just say g of x is equal to, okay, we have -3, or I'm sorry, we have 3 for the vertical asymptote. So we're going to put x minus 3 on the bottom here. And then the top, we want a -1 in there. So I'm just going to put -x. You could even just do a +1 on here. It doesn't matter because the 1 and the 3 are meaningless. You get -x over x is equal to 1, and this would work for your answer. Again, there's infinitely many other answers you could have in there. This is just what I'm putting. And part C, I'm actually just going to get rid of because it's kind of beyond the scope of the class, so we're not going to worry about it so much. All right, so that is 5 example problems involving horizontal asymptotes. If you have any questions about anything in this video, let me know.